All right, welcome to 7.4 notes. This is systems of nonlinear equations in two variables. Our goal today is to solve systems of nonlinear equations in two variables which may include rational functions, circles, lines, and parabolas. So for this first part, review questions, go ahead and pause the video, work these out, just a little refresher on some of the things we've covered. I'll come back in a moment. Pause. Here are the answers for those three questions having to deal with some of the content we did just previously. Let's take a look at what we're doing today. So recall that solutions to systems of equations are points of intersection on their corresponding graphs. When solving a nonlinear system, it is important to consider the possible number of solutions or intersections that can exist. For example, if you have a line and a parabola, well then you could intersect at 0 points because they could not touch, or you could intersect at one place in particular because it's tangent to the parabola, or you could cross the thing twice, so there should be 2 times. Same thing with a circle. If we're thinking about a circle, for a circle we would have and a parabola. Well, first of all, they may not touch at all, or the parabola is tangent to the circle, or you have the circle and then you have the parabola where it's just barely coming into the circle. There would be 2 points of connection. Or you could have the parabola tangent to the circle on the far side so that you have created 3 points, or it could be 4. Just depends on how it is. If your parabola goes all the way to where the vertex is outside of the circle but everything else is inside, you could have any of those situations here. Now we're going to talk about solving nonlinear systems by using substitution and sometimes by using elimination. Here we have a what do we call it? A rational expression for the first one. That would just be we could say y is equal to 4 over x. And the second one is a circle. It's the basic equation of a circle. So now we want to use substitution here to solve this out. So I'm going to replace the y in the second equation with what y equals. So we're going to have x squared plus, this is going to be 4 over x, and we would square all that, is equal to 8. So now we have x's, so we're going to say x squared plus is going to be 16 over x squared is equal to 8. Now, we got to figure out how to solve this particular thing. And when you solve it, want to kind of think about in terms of getting rid of your x squared in the denominator of this thing. That's really our goal here. We have a couple different ways we could do this, but one way in particular is just to multiply everything by x squared, every single term by x squared. That would give us an x to the 4th plus 16, because remember, if we multiply it by x squared, those are just going to go away, is equal to 8x squared. So now I have that situation. Now I need to factor this somehow. Well, that means move everything to one side because this is in quadratic form, so to speak. So we have minus 8x plus 16. All that's going to equal 0. And then I need to factor this. Well, looking at it, we could do this a couple of different ways. One way would just be to use a big X. The big X would imply that we have factors of 16 that add up to negative 8. Well, that would be negative 4 and negative 4. And since we have two negative 4's, that would be x squared minus 4 and x squared minus 4 is equal to 0. Solve for one of them because they're both the same. So x squared minus 4 is equal to 0. That means then that x squared is equal to 4, and x would equal plus or minus 2. So we have two solutions here because we have two x's. Now I need to go back up and solve for y. So I would plug back in to the y equation to get an answer to this one, to solve it out. That would mean then that y is equal to 4 over, then it would be 2, so that would be 2, and y would equal 4 over negative 2, which would be negative 2. And so now I plugged in the first one, I plugged in 2 and I got 2. For the second one I plugged in negative 2 and I got negative 2. So those would be the two answers that we would have. Hopefully that makes sense. Depends on which one we use. Let's take a look at this next one. This next one is a line and it looks like another circle. Here we're going to have to do something in particular. One second. So for this one, I'm looking at here, I've got a couple of y's. I don't want to have to replace two things. So the thought process for this one should be, let's eliminate the x here. So I would say that x is going to equal negative y minus 3. And then I'm going to take all that and I'm going to plug it in right there. So I'm going to have the following. This is going to be negative y minus 3. I'm going to square that. Plus, this is 2y squared equals 12y plus 18. Now I'm going to solve this. So when I multiply this squared situation, I'm going to get negative y times negative y. You can write it twice and do it, or just do it. This is going to be y squared. This is going to be negative y times negative 3. That's plus 3y. And a plus 3y gives you a plus 6y. And then negative 3 times negative 3, that's a plus 9. So you're going to get all of those things plus 2y squared is equal to 12y plus 18. So we're going to combine our y squareds. Plus 6y plus 9 is equal to 12y plus 18. I'm going to move everything to one side, so 3y squared, subtracting 12y, so I'm going to get negative 6y. And then subtracting that, I'm going to get negative 9 is equal to 0. I'm going to take 3 out. When I divide out the 3, I'm going to get something that looks like this. And now I got to factor this thing. Factors a negative 3 that add up to negative 2. That's going to be y minus 3. And this is y plus 1. Set each one of those equal. Y is going to equal positive 3 and negative 1. Here are the two that's going to be. And then I need to solve this for the other ones that I don't know. So I'm going to go back to my original of this equation here. You can use the original, or if you're confident in your math, just use the one you solve for x on. So x is equal to, this is going to be negative 3 minus 3. Well, that's going to be, x is going to equal negative 6. And then x is going to be equal to negative 1 minus 3. So x would be 1 minus 3, which is negative 2. So you're going to have our two solutions here. One of your solutions will say, when we put in 3, we got negative 6. Whoops, sorry. I want to write those the correct order. That would make sense. I got negative 6 when I plugged in 3. And I got negative 2 when I plugged in negative 1. Those would be the two places where these meet each other. So hopefully that makes sense. These were using substitution. Now, the elimination method, when you're using elimination, it's kind of the same idea here. The only difference is now I want to eliminate a variable, and I can do that in this one. I couldn't necessarily do that in either of these because we had squared situations versus just x's and y's. So elimination doesn't really work here, but elimination will work in this particular one. Because now I have x squareds, I have y squareds, and it's no different than what you've done in the past for elimination. I'm going to look at this one, and I'm going to try to pick the one that makes the most sense to eliminate. To me, it looks like if I multiply this whole thing by negative 2, I will eliminate the y squareds. So that's my goal here in this one. I'm going to end up with 3x squared minus 2y squared is equal to negative 5. And then I'm going to have negative 4x squared. I'm going to have plus 2y squared. And then I'm going to multiply those. I'm going to get a positive 4. And once we do that, we get rid of these. This becomes negative x squared is equal to negative 1. So x squared must equal 1. So x would equal, sorry, my pen is not working real well, plus or minus 1. So now I have two answers for x. I'm going to go back and then try to find the x's that go with them. So I'm going to use one of the equations. I'll use the first one. So for the first one, I'm going to replace the x's. So the first one, I'm going to replace the 1 minus 2y squared is equal to negative 5. So this is going to be 3 minus 2y squared is equal to negative 5. I'm going to subtract. I get negative 2y squared. This one is going to give me negative 8. I'm going to divide. I get y squared. That's going to give me 4. So now it's saying that y is going to be plus or minus 4. Now, here's the thing with this one. When you do this one, you have to keep in mind that my x could be plus or minus 1. But now I'm getting two answers for my y, which tells me two of my answers are going to say the following. They're going to say 1. When I put in positive 1, I got a plus 4. And when I put in positive 1, I got a negative, whoops, not 4, 2. Silly. Let's see, 2 right there. Sorry about that. That would also be a 2. And then I got a negative 2. So there are the first answers. Then I have to go back and do the same thing, but putting in negative 1. Well, if I put in a negative 1, we should hopefully see that it's just going to square, and I'm going to get the same two answers, which means I also am going to have negative 1, 2, and negative 1, negative 2. So this one has 4 answers to it. This one is a, what do we call this one? In conics, we would learn how to do this one. We will come up on conics here soon. We would understand what this is when we actually do it. So just bear in mind, I'm not going to explain it now. We'll talk about it when we get to conics. So this next one, same idea. I'm trying to get rid of one. When I try to get rid of one here, the y's go away already, so it's not like I have to do a lot of work to eliminate the y's. I think I'll eliminate those. Now, these are not the same term, so x cubed plus x squared equals 0. That's what this one is saying. And now what would I do? Well, factor here, so I'm going to take out an x squared. That would leave me with x plus 1. That means then that I would have an x squared is equal to 0, so x would have to be 0. And I'm going to have an x plus 1 equals 0, so x would equal negative 1. Now I'm going to take that and I'm going to plug it back in and try to solve for my y's. So in the first equation, it really doesn't matter which one you use here. In the first equation, it's going to say 0 cubed plus y is equal to 0, so y is equal to 0. And in the second one, I'm going to plug in negative 1, so when I get negative 1 cubed plus y, that's going to be 0. So this is negative 1 plus y is equal to 0, so y has to equal 1. So I'm going to have these two answers here, or sorry, two answers. We're going to have one that says 0, and when I plugged in 0, I got 0. And the other one, I'm going to have a negative 1, and when I plug that in, I got a positive 1. So I should end up with those two answers for this one. All right, last one. You are going to do this one on your own. Pause the video, work it out, and then come back and see what we got. You can choose whichever method you want. Pause the video. So this should take us back to some algebra stuff. You got to know your factoring, got to know how to do things. I would take a substitution track and substitute what y is equal to into the first equation. Once you do that, then it's a question of just working through it, making sure it comes out the right way. So here, plugging that one in, then I rewrite it and I subtract 12 because it's a cube function. In order to factor a cube function, you have to set it equal to 0. Then this is 4 terms, so you group the first two, group the second two, you take out what they have in common. You end up with an x squared minus 4 plus x or times x plus 3 is equal to 0. Set each one equal to 0 and solve. So your 3x's are plus or minus 2 and negative 3. Then I just took the first equation and I plugged in those values to see what I would get in terms of answers. I got a 0 for when I put in negative 3, I got a 20 when I put in 2, and I got a 4 when I put in negative 2. The only thing I would say here, make sure you check against that last, the actual one over here. So if you take your, say, negative 3 and you plug it in to this equation, you're going to get negative 27 minus 27, that's 0, if you're using the second equation to find your y values. It's a good idea to check in both equations so that your points make sense when you are done. But this should be how it works out. Hopefully this makes sense. If you got questions, make sure you ask your teacher. Have a good day. Bye.